Okay, let's go and get started. Today, make sure you watched class 13 as well, but also I want you to watch class 14, which is introducing the lab that we're going to do today. So if you did not, watch class 13, go ahead and watch that. But then before you start the lab today, go ahead and watch this one as well. Now, what we're going to do today is talk about what we need to know to do this lab on pipes. And the lab on pipes, let's quickly review those. We covered them in lecture 12. They were mentioned also and reviewed a little bit in lecture 13. So if you forgot or didn't watch those two, go back and watch those. But we're going to review what we need to have from those today. So today, you're going to be using pipes. So let's spend a little time reviewing how they work. And the general concept is of a pipe as a communication mechanism is a lot like a physical pipe in some sort of system. So in other words, you have two ends to a pipe. Here's one end over here. Here's the other end over there. And what we have on each of the ends is a process. So there's a process here, a different process over there. And that allows this process to run concurrent with this one at a different rate than that one, but communicate through that pipe by putting information in and having it show up on the other end. So a little more review. Pipes have been used in operating systems for a long time as a way to connect processes together, a way to communicate between processes. And the general concept is, here's the pipe. It's got an end that this process puts data into, an end that this process pulls data out of. And the pipes are unidirectional by nature in operating systems. In Python, they're bidirectional. You can put stuff in and have it go that way. You can put stuff in and have it go that way. So behind the scenes, it's kind of like two pipes rather than just one. But in the general sense, in operating systems, typically it's a unidirectional mechanism that one process puts data in the right end, another one pulls the data out of the read end of the pipe. So kind of like a sewage system. The water flows or sewage flows one direction. Okay, now as an example of where pipes get used in operating systems, if you've ever used Unix and you have a command line like we have here, where we're using a number of different commands and connecting them together. So cat essentially opens a file and displays its contents to the standard output, in other words, to the console. But we can say, rather than having the output of this go to the console, we can pipe it to the input of another process. And this process, grep, looks for a pattern. If it finds that pattern, it passes any lines that have that pattern along. And then with that could go to the console, or we could route that output to the input of the WC process, which is word count, and that counts the number of lines. So in other words, what this command line is going to do, it's going to tell me how many lines have this pattern on them. How many lines include that pattern by doing word count -L, that's an L, not a 1. So what you'll notice is by doing this, you could do something that would take a program by just normally take a programmer to write. And we can do it with a command line by hooking together these things. Display the file, look for any line that has this pattern, and then count the number of lines that have that, and then output that. So that behind the scenes is going to launch 3 processes: cat, grep, word count. But the operating system is going to use pipes to plumb those streams together. So the output of one goes to the input of the other, and the output of that one goes to the input of the other, and the output of this one, the word count, since it's not piped anywhere, it's going to go to the console. So we're going to simulate that with our lab today. We'll look at the lab in just a second. But here's what's going on behind the scenes when we do that command line. We get these 3 different processes: cat file.txt, grep yoast, word count -L, and the standard out of one goes to the right end of this pipe. Standard in of the next comes from the read end of that pipe. Standard out of this one goes to the second pipe. Standard in of that one comes from the read end of that pipe. And so when we run that command line, 3 processes get launched. They all communicate with each other, passing data from one to the next, and this one its output goes to standard out. So the command interpreter launches those processes, it creates the pipes, and it connects them to the right places on these. And you might remember from systems programming class, standard out of a C language program or standard in of a C language program. Every program has those streams. There's also a standard error, which isn't shown here, which by default usually also goes to the console. But you'll notice that we can launch 3 processes and the operating system will plumb them all together like this. The command interpreter will do that. Oops. Whoa. Stop. Okay, here we are. All right. So one thing to note is the programs don't even know that they're talking to each other. They're not written to talk to each other because the operating system hooks up standard out and standard into those pipes. We're going to do it a little bit differently in our simulation today. We're going to write the code that actually creates the pipes and then links those programs up to use them. All right, so here pipes, one thing to remember is pipes are an operating system mechanism that exists in Linux, Windows, Mac, which is a form of Unix, other operating systems. And the reason for that is that they're a very powerful inter-process communication mechanism that's also very simple. And while we could have the operating system do that, we can also manage, create our own pipes and manage them in code that we write. And that's what we're going to do in the lab today. Now, the easiest way to do that in Python is using multiprocessing.pipe. And a pipe creates an object that's similar to an OS pipe, but is duplex by default rather than one directional, meaning that both ends can read and write through to the other end. We're not going to use it in a bidirectional way. We're going to use it kind of just as if it were a unidirectional pipe. And it'll work that way. It's fine that way. But when we create a pipe, it creates 2 objects, connection 1, connection 2. So pipe supports an optional parameter duplex equal true. If you set it to false, then connection 1 can only receive. That becomes the right end of the pipe. Connection 2 can only send. Becomes the read end of the pipe. But if we just call it with duplex equal true, then you could read and write to both connections or either connection, like a telephone. Each end has a telephone. You can talk in it. You can listen in it. But we're going to use it more in a unidirectional way for this lab. All right, so here's a quick example that we saw of pipes being used. And this is a pipe that has a special message that gets sent to tell the program or tell the process to quit. In other words, each of these, you'll notice the consumer, it has an infinite loop while true. How does it get out of the loop? If it ever receives the message end, then it breaks out of the loop and it closes the pipe. Down here in our main program, we create a pipe that has connection 1 and connection 2. And then we're going to pass one end to the producer. We're going to pass the other end to the consumer. And then the producer is going to put messages into the pipe. The consumer is going to pull messages out of the pipe. So pipe.send puts stuff into the pipe. Pipe.receive pulls things out of the pipe. And it's going to keep doing that until it gets to end. And really, that's all there is to it. So we create the pipe. We pass one end to one process, the other end to the other process. They then use that, the producer by stuffing things in one end, the consumer by pulling things out of the other end. And once those processes complete, they close the pipe, their end of the pipe, and then we're done with the program. So when you go to work on the lab, you might refer back to this example. Now, one thing, pipes versus queues. Pipes only allow 2 endpoints. They're not safe with more than one process reading or writing to the same connection. They're designed to be just like a pipe. There's one end that stuff gets put into, the other end that stuff gets pulled out of. In Python, they're duplex by default. You're not going to use the duplex capability ever for this lab. Queues, however, allow multiple producers and consumers. They're safe to use with any number of readers and writers, any number of things putting things into it, any number pulling them out. They can emulate a pipe if you only have one writer and one reader process. Queues will work the same way, but for this lab, I want you to use pipes. Pipes, if you only ever have a producer and consumer, they can be faster because they're built directly on top of the operating system implementation of pipes. And you could use those operating system pipes directly if you wanted to, although that's a little less portable. So you could say import OS and do os.pipe rather than multiprocessing.pipe. And that will give you the read end and the write end that way. We're going to use multiprocessing.pipe for this lab. Now, let's take a quick look at the lab assignment. So let me switch over so you can see that. And let me go ahead and open that up here. And switch the camera over so you can see it. All right, so here's the lab. For this lab, we're going to be kind of emulating that behavior that you would see in Unix. So for example, this cat, a file, grep yoast, word count, tacl would launch 3 processes. The command interpreter then start, and then each of those processes create the pipes, connect each to the standard and standard out. Well, we're going to do something similar to that, but we're going to do it in Python code. So we're going to write a Python program that kind of simulates that by creating the following functions that are then going to be launched as processes. So in other words, we're going to make a cat function. And the way the cat function works is we're going to pass in a file name and then the pipe that output that's going to go into. And here, this pipe out, that's out with respect to this cat function. That's where it's going to write things out to. That's the output of that function. Now, I have some comments here that have the description of what that does. It should open that file with this name, and it will loop reading one line at a time, and then it will write each line to the pipe that was put into here. Once all the lines have been read and written to the pipe, the function should write none to the pipe and then terminate. And the reason we're writing none to that pipe is we're putting that special message in there that is going to allow the next program to know that we've reached the end. It's kind of like an end of file or an end of stream marker that we're just going to pass none in for that. So in other words, the next thing in the chain, grep, is going to read a line from the pipe. If the line read is none, then it will write none to its output pipe, and then it will shut down. So it's going to pass the none along to the next one, so it can end, and so forth all the way through. If it's not none, that means we got something valid. We're going to take that and search for the pattern to see if that pattern is contained in the line. If it is, then we pass that line along. If the line does not contain that pattern that we were looking for here, then we ignore it and we just go back and read the next line. Now, the word count has just pipe in and pipe out. It's just going to count up the number of things, and it's going to write that to pipe out like this. So it's going to count the number of lines that came in. In other words, just going to read from the pipe, add to a counter, read from the pipe, add to a counter, and so forth. And once it gets none, it'll exit the loop. And after exiting the loop, it'll print out how many lines there were that were actually received. And then we're going to make a printer that anything that comes in the pipe is just going to print that, and until it gets none. When it gets none, it ends. And then what I want you to do after you've created those, you're going to create a process for each of those functions up there. And the pipes that interconnect them are going to get passed in when you create those processes. And I want you to simulate these kind of two things. You're going to have two programs, one that simulates catting sonnets, connecting with grepping for the and connecting to printer. And then I want you to also then insert in that this word count process. So sonnets, cat sonnets connected with grep, connected with word count, connected with printer. So this one will print out all the lines that have the on them. This one will print out all the count of how many lines there were. So note in your main program, you're going to have to create the pipes to be passed to those functions. So how many pipes will we need in this one? Well, we'll need one here and one there. So you'll need 2 for program 1. You'll need 3 for program 2. And you'll need to pass those into those functions when we create those processes. Now, you might want to put an enter exit at the end of your main as a way to ensure that you see the result of that. But and the reason you need to do that is, remember, if If you run this in idle, you won't be able to see the output because of the way idle is written. If you use PyCharm, I think it works, or if you run it from the command line, it'll work. So if you just run that directly from the command line, that program, you can double click on it, or you could go to the location of it and do py space and then the name of the program. You could run it directly that way, and you'll be able to see the output. But if you just double click on it, it'll run it in a shell, and then when the process closes, it'll immediately close. So that's why I say you might want to add this enter to exit at the end of your main. So you can see that when you double click on it to run it. Okay, so that's it. One thing you say, well, where do I get this sonnets file? That's been posted to the course page as well under files. And I also posted kind of a skeleton of the program that has these things in there. So you can have a place to start, so you don't have to retype any of this. You just start with the skeleton program, fix it, actually write the code to do what this says, and then run that. And what you should see is all of the lines that have THEE on them will show up with program 1. With program 2, you'll see the count of how many lines had THEE on them. And feel free, if you want to play around with this, to change this around. So you could have word count just on sonnets.txt, which will show you how many lines there are in the entire file. You could also, if you wanted to, play around with gripping for different patterns. But these are the only two that you need to submit. And as a example of what file it is that I'm expecting you to look at, that sonnets is a collection of all of Shakespeare's sonnets in a text file. And I believe I can show that to you really quickly here. So here's what that looks like. There's sonnet 1, sonnet 2, sonnet 3. So this is all of Shakespeare's sonnets. So there's quite a few of them there. So you might wonder, well, how many lines have "the" on them? Well, you're going to find out. What do those lines look like that have "the" on them? And so it's actually interesting to look through these. One thing that I would say about this is you could really feed any file into your program rather than sonnets. It would tell you how many lines, how many times that pattern occurs in there, how many lines have that pattern that occurs in it. But just use this file for right now. One thing as an interesting aside, for those of you who are in the AI class, I once made an AI that used the patterns of Shakespeare sonnets in a probabilistic way to train this system so that it wrote poetry that was like new Shakespeare sonnets based on the way these were. So in other words, it would create patterns of output code that were based on Shakespeare sonnets but had never been written before. So it's kind of like Shakespeare wrote those things but also didn't write them. And some of them that program generated were actually very poetic and seemed very deep and meaningful, even though it was all just done through being trained on this stuff. So if you want to play around with something like that in your AI class, that can be fun as well. But it was interesting that if you read through those things that the computer generated, some of them sounded very much like a Shakespeare sonnet, but one that Shakespeare himself never wrote. And it was just because I trained it on this as the input text. Anyway, we're not doing that for this assignment, so that's an important. The other part of this is this pipes_skeleton.py. You might want to use that as your starting point for getting started on the lab assignment. And let's go back to the presentation briefly. So we looked at the lab assignment. You have enough information. You have that skeleton, so you can get started on that. And so I'm going to keep the lecture short today, so to give you time to start working on that lab. So go ahead and work on that today. Seriously, don't procrastinate. Don't wait. Work on it. It's not a lot of code you have to write. So if I were you, I'd go and get started on that, see if you can get that done. And what's cool about this lab, I think, is that's the way that operating systems connect things, is with that pipe mechanism. And you can do the same thing with processes in Unix. And that happens a lot in systems where you have some sort of chain of things hooked together in a build environment or a render pipeline. where the output of one program goes into another, and the output of that goes into the next one. And so you might say, well, you feed into the render environment a list of, or the geometry of the frames. It feeds it in, renders a frame, passes it on to post-processing, or lighting, passes it on to post-processing, passes it on to output, which then stores it in the video file. And you can do all of that with those things overlapping each other rather than one program doing all of it, which can greatly improve performance, especially since processes can run on different cores or different processors. So it creates this thing where you can get a very high level of performance by piping together different processes so they can communicate with each other. And pipes being supported in the operating system, super efficient and high speed to program with. Okay, well, that's it. Stay safe. Get to work on your lab. If you have any questions, as always, shoot me an email, send me a text, let me know, and I'll see if I can get you unblocked as quickly as possible. Other than that, make sure you have watched both Class 13 and 14 that have been posted, and work on your lab.